Good morning, students. Today we will start new chapter number 4, motion in a plane. In last chapter we have discussed about motion in a straight line. Straight line means only two directions are possible, right side or left side, upward direction or downward direction, north or south. And to differentiate these two different directions, we have used plus and minus sign. We have used plus and minus sign. For upward direction, if it is positive, then for downward direction, it is negative. But in this chapter, we will study motion in plane, means in 2 dimension or in 3 dimension. Then yes, we have to take more than 2 directions. Then how to represent more than 2 directions? Okay, what is difference between scalar quantity and vector quantity? What is circular motion? What is projectile motion? Okay, we will study this each and every topic in this chapter. Okay, see, starting from motion in a plane. First point of this chapter is the physical quantities are classified as scalar quantities and vector quantities. Yes, you know what is difference between scalar quantities and vector quantities. The basic difference between them is direction. Scalar quantities requires only magnitude for full information, while vector quantities need magnitude as well as direction. Magnitude as well as direction. Okay, with some examples, see here. The basic difference between them is direction. Yes, you already know it. Okay. Scalar quantities are quantities for which complete information is obtained by knowing their values only. Examples are temperature, mass, density, time, etc., etc., etc. Okay. To find complete information about what is my mass. Okay, so my mass is given by only some value. Mass is equal to 56 kg. So 56, that is numerical value, and kg, that is unit. So yes, it is enough to define or to describe any scalar quantity. To describe any scalar quantity. Magnitude and unit. Magnitude and unit. Clear about this? Okay, so any scalar quantity we have to represent as magnitude and unit. Clear? Okay. For scalar quantities, yes, you know how to add, subtract, multiply and divide. Yes or no? That is called ordinary algebra. Okay, so for scalar quantities, for example, mass, m1 is equal to 5 kg. For example, I have m1 is equal to 5 kg and I have m2 is equal to 10 kg. So yes, you know how to add these two mass. m1 plus m2 is equal to 5 plus 10 is equal to 15 kg. So yes, in case of scalar quantities, addition, subtraction, multiplication and division can be done like those of usual numbers. You know it. You know plus, minus, multiplication and division of scalar quantities. Okay. Okay. What is new? New is vector quantity. See, what is vector quantity? The quantities which need direction as well as magnitude or values. Direction and values to be completely known are called vector quantities. Velocity, acceleration, force, torque, these are examples of vector quantities. Okay, we know one difference between path length and displacement. Path length, it is always positive because it is magnitude, it is scalar quantity, while displacement, it may be positive, negative or zero because it is vector quantity. For velocity, you have to indicate direction. Remember, plus or minus indicates direction. Okay, so the quantities which need the direction as well as values to be completely known are called vector quantities. Such examples, okay, the vector quantities obey specific laws of combination, means scalar quantities are added, subtracted, multiplied and divided by usual numbers. for vector quantities, such rules are not obeyed. They have some specific rules. Vector addition, triangle method, vector addition, law of parallelogram, scalar product, dot product. Okay, these each and every processes are new that we will study in this chapter. Okay, so your chapter starts with one difference. Okay, what is difference between scalar quantity and vector quantity? Clear about this? Okay, now we will see in detail about vector quantities. Okay, what is vector quantity? Our focus in this chapter is about vector. See, students, vector is very important topic, because if you know what is position vector, what is displacement vector, how to draw vectors, how to take their components, how to resolve vectors, what is value of component, then you will easily understand next chapters of 11 and totally 12th. Okay, so vector is very important concept in physics. Vector is very important concept in physics. Okay, so take care. See, what is vector? Vector quantities is represented by putting an arrow on symbol of that quantity or as bold letter. For example, we know that force is vector quantity. So how to represent vector quantity? Okay, force. We know that force is indicated by capital F. Okay, so you have to put arrow. You have to put arrow on each symbol, or you can write bold F, or you can write bold F. Clear? So how to write vector quantities? F arrow or only bold F? Clear? Yes. In your textbook, this notation is used, but in notebook we will use this. In notebook we will use this. Clear? Similar example, velocity is vector quantity. How to represent? Velocity symbol V and arrow above its symbol or bold V. Clear about this? Okay, so see how to represent any vector quantity. F is vector quantity. If I say I have one quantity like this, then tell me it is scalar or vector? Yes, it is scalar. M, that is mass, no arrow, means it is scalar. Okay, now value of vector quantity is shown by putting the symbol of quantity in modulus. For example, I have vector A. I have vector A. For example, I have vector A. Then how to find value of vector A? In modulus A or only A. In modulus A or only A. Then see, you have to remember these three things. A arrow means it is vector. If you have any symbol of quantity with arrow above it, then it is called vector. If you have only symbol, no bold, okay, then it is called magnitude. And it is one more method to represent magnitude. Vector in modulus. Okay, so magnitude or value we can represent with the help of these two methods. Most of 99% we will use this method to represent magnitude. Clear about this? So remember, any vector quantity you have to represent with arrow above each symbol. Its magnitude only letter or arrow in modulus. Clear? Okay, now vector. See, each and every topic in this lecture is important because it is basic of vector. Okay, see, representation of vector by graphical method. How to represent any vector? See, carefully here. An arrow is drawn such that the length of this arrow is equal to the value of vector. And head of arrow is put in direction in which the effect of vector quantity is prevailing. Arrow can be drawn from any points. See, this is theoretical. Now we will understand how to draw any vector. I have one example. See, a train moves with velocity of 40 km per hour south to north. So see, here it is north, it is south. Clear about this? Okay, a train moves with velocity of 40 km per hour south to north. Velocity, vector quantity. Velocity is vector quantity. Its magnitude is 40 km per hour. So first of all, you have to take some scale. First of all, you have to take some scale. For example, I am here taking one scale. 1 centimeter is equal to 10 km per hour. 1 centimeter is equal to 10 km per hour. So 40 km per hour means 4 centimeter. Okay, 4 centimeter is equal to 40 km per hour. Means you have to draw arrow of length 4 centimeter. You have to draw arrow of 4 centimeter. But if you know arrow, how to draw arrow? See, it is arrow. It is arrow. It is called its head and it is called tail. It is called tail. Clear about arrow? Okay, it is called head and it is called tail. See, what is the head of arrow is put in direction in which the effect of vector quantity is prevailing. Here train is moving from south to north. Train is moving from south to north, means it is moving in north direction. So you have to draw arrow such that its head is in north direction. Its head is in north direction. Clear about this? Because train is moving from south to north. And what is length of this arrow? 4 centimeter, which is equal to 40 km per hour. Which is equal to 40 km per hour. Clear about this? So you have to remember how any vector quantity is represented. You will be given magnitude and direction. You will be given magnitude and direction. Okay students, see, next point is position vector and displacement vector. Yes, in chapter 3 we have already studied about position and displacement. First of all, to find position, what we have to select? One reference point. One reference point. Here, similar thing, see, position vector and displacement vector. First of all, to find any position, to define any position, you have to select one reference point. And reference point we are choosing origin of coordinate axis. Origin of coordinate axis. See, x-axis, y-axis and z-axis perpendicular to God coming outside, and their intersection is called origin. Their intersection is called origin. So here in this case you have to define position of each and every point with respect to O. Define position with respect to O. Okay. See, for example, it is path of one particle. It is path of one particle. Okay, one particle is moving. Okay, and it is path of one particle. Let at time t is equal to t1. At time t is equal to t1. Particle is here at point P. Particle is here at point P. Clear about this? Clear about this? At time t is equal to t1. Particle is here at point P. Then how to define position of particle at time t1? See, draw one vector. One vector means one arrow. One arrow from origin to that given point. To that given point. Clear about this? Tail of vector is at origin and head towards that point. Towards that point. Okay, so see, it is one vector. It is one vector. Clear about this? Again, at time t1, particle is at point P. Then how to define its position? You have to draw vector from origin to one vector like this. Okay, suppose we are giving some name to this vector. Let it is R1. Let it is R1. Okay, then what is R1? R1 is called position of particle at time t1. At time t1. Clear about this? R1 is called position vector. R1 is called position vector of particle at time t1. Clear? Now see, particle is moving on this path, is moving on this path. At suppose time t2. Here it is at point Q. Particle is at point Q. Okay. At time t1 it is at point P. It is moving. At time t is equal to, it is at point Q. Then again, what is position at this point? Position at this point means you have to draw one vector from origin. You have to draw one vector from origin. Okay. So this vector, suppose it is named R2. This R2 is called position vector. It is called position vector of particle. Position vector of particle at time t. At time t. Clear about this? What is position vector? Simple. To define position vector, you have to draw an arrow from origin to that point. From origin to that point. Clear about this? Now see, P is initial position, Q is final position. You know what is displacement? Displacement means final position minus initial position, or shortest distance between final position and initial position. See here how to find or how to draw this displacement vector. Okay, here it is initial position, final position. Draw an arrow from initial position to final position. Draw an arrow from initial position to final position. Draw an arrow from initial position to final position. It is nothing but displacement, change in position, delta R. Okay, so here what is delta R? Delta R is called displacement vector. Delta R is called displacement vector. Clear about this? So see, here your chapter starts with these three, with these two definitions, position vector and displacement vector. Position vector R1 and R2, and delta R is called displacement vector. Clear about this? Okay. Now next point, see, equality of vectors. Equality of vectors. Okay, equal vectors. What is definition of equal vectors? Value and directions are equal. No, value and directions are equal means, see, in first point, we have already discussed any vector quantity you have to represent by an arrow. Arrow having some length and head in some particular direction. Head indicates in which direction quantity's effect is prevailing. Okay. Equal vectors means values and directions are equal. Values means their lengths are equal. Values mean length of arrow is same. Length of arrow is same. And direction same means head they are in same direction. For example, see, it is vector A and it is vector B. And it is vector B. See, from this figure it is clear. Both arrow have same length. And head they are also in same direction. Means value and directions are equal. So such vectors are called equal vectors. Okay, another figure. If one vector is in this direction, another vector D, it is in this direction. Then again, this C and D, see, their lengths are equal, means their magnitudes are same. Head in same direction, means direction is also same. So they both are in same direction. Clear about this? Okay. For equal vectors, what is angle between? What is angle between two vectors? Angle between two vectors, theta is equal to 0. Theta is equal to 0 because they are in same direction. Okay. Now, parallel vectors. What is definition of parallel vectors? Same direction, but magnitude can be equal or different. Magnitude can be equal or different. For example, if I have one vector A in this direction, one vector B in this direction. So see, from this you can say length of vector A is more than length of vector B. Means magnitude of A is greater than magnitude of B. Clear about this? Magnitude of A is greater than magnitude of B. Magnitude of A is greater than magnitude of B. But the direction is same. See, this head is in same direction. So such vectors are called parallel vectors. Such vectors are called parallel vectors. Clear about this? Okay. Yes, again in parallel vectors, angle between two vectors is 0. Third one, anti-parallel vectors. Anti-parallel vectors means two vectors when they are in opposite direction. When they are in opposite direction. Suppose one vector A is in this direction. See, it is in this direction. And another vector B, it is in this direction. See, they both are in same direction. They both are in opposite direction. They both are in opposite direction. Then such vectors are called anti-parallel vectors. What is angle between two opposite direction? Opposite direction means angle between them is 180 degree. Angle between them is 180 degree. Clear about this? Okay. Now last one. Parallel vectors. Parallel vectors means vectors which are not parallel or anti-parallel. Means angle between them is not 0 or 180. 0 or 180. Such vectors are called anti-parallel vectors. For example, if it is vector A and if it is vector B, okay, is vector A and B, they are parallel? No, they are not anti-parallel. So vectors which are not parallel or anti-parallel, they are called aparallel vectors. Clear about this? So this equality of vectors, you have to remember each and everything. Equal vectors, parallel vectors, anti-parallel vectors, aparallel vectors. Here value and direction both are equal. Here only direction is equal. Here direction opposite, and here they are not parallel or anti-parallel. See, in this case, here magnitude can be equal or different. Can be equal or different. So yes, if I draw two vectors C and D like this, these are called parallel vectors also. These are called parallel vectors also. So we can say each parallel vectors are equal vectors, but all equal vectors are not parallel vectors. Clear about this? Okay. See, vector is again important topic. So if you have any doubt in these basics, okay, send me doubts on my WhatsApp number. Clear your doubts. Okay.